So now, after discussing the concepts that is needed to solve the problem, now let's try some problems. Suppose a classification model with results is given. Let's assume that these are the marks. Let's assume these are the marks where the results says that true positive is 40, true negative is 30, false positive is 10, false negative is 20. Now we are supposed to calculate evaluation metrics. To calculate accuracy, the formula is TP plus TN divided by total. Total is nothing but you add all these parameters, it is nothing but 100. Therefore, TP is 40, TN is 30, 70 by 100, 0.70. So the accuracy is 70%. The overall correctness of this model is 70%. Next, precision. TP by TP plus FP. So TP given, that is true positive given, is 40, and true positive and false positive together it makes 50. So 40 by 50 is 0.80. 80%. Precision is 80%. Recall. True positive whole divided by true positive plus false negative, 40 by 40 plus 20, which is nothing but 40 by 60, that is 0.67, which is nothing but 66.7% is the recall. F1 score formula is 2 into precision into recall divided by precision plus recall. So precision is already we have got as 0.80 and recall we have got 0.67. So divided by same thing, it is 73%. Now after once these parameters are found, we can even construct the confusion matrix. This is how we construct the confusion matrix. AP is actual positive, AN is actual negative, PP is predicted positive, PN is predicted negative. This is what was the confusion matrix what I taught you. Now what is the TP value? 40. FN is 20. FP is 10. TN is 30. So this is how we build the confusion matrix. Also, this is how when the true positive, true negative, false positive, false negative is given, we can calculate various evaluation metrics. Next problem, data is given such a way that actual value, predicted value. So Y denotes actual value, Y cap denotes predicted value. We are supposed to calculate mean absolute error, mean square error, root mean square error. To do this is one trick is there. We need to calculate some information and keep. Write all actual value 20, 30, 40, 50. Next, write all predicted value 18, 33, 37, 48. Therefore, the error is nothing but difference between actual value and predicted value. 20 minus 18, 2. 30 minus 33 minus 3. 40 minus 37 is 3. 50 minus 48, 2. If this is the error, absolute error is nothing but ignore the signs and rewrite it as it is. 2, 3, 3, 2. So we ignore the minus sign. Next step is whatever absolute error we have got, square it and keep it ready. 2 square is 4, 3 square is 9, 3 square is 9, 2 square is 4. Now, mean absolute error. Add all the absolute error and divide by total number of value. Total number of value given is 4. Therefore, 2 plus 3 plus 3 plus 2 divided by 4, which is nothing but 2.5 is the mean absolute error. Next is mean square error. Whatever the error squaring we did now, add all this and divide by 4. This 4 plus 9 plus 9 plus 4, which gives us 6.5. Next, root mean square error, where root mean square error is nothing but square root of MSE. Square root of MSE is 6.5. Therefore, the square root of 6.5 is 2.55. So this is the two types of problem where given true positive, true negative values, we calculate various evaluation metrics and represent the confusion matrix. Next kind of problem is given actual value, predicted value, we calculate various errors. Next comes the concept of representing the data by using ordinal encoding, one hot encoding. See, when ordinal encoding is there means the data set should have some order. If some order is there, if some ranking is there, then you can represent that. If such a way that there is no order, only the unique category is identified and we encode, is known as one hot encoding. Now I'll show here. Let's assume that there is some tourist place where the rating is given for the place is like good, bad, average, good and bad. So here ranking is there. For example, first is we can consider good, bad, average. We can give the ranking like this. I'll just indicate always, we can give like this: bad is 0, average is 1, good is 2. So this is the ranking. If it is bad, 0. If it is average, 1. And if it is good, we can give the rating as 2. This is how we are giving the ranking based on some order. Now I can give the ordering like this. So good is again 2, bad is again 0. Now if I want to represent ordinal encoding, what comes first? 2. Next, bad. Next, average 1, comma, good 2, bad 0. Suppose if it continues with good, then I will write 2. So this is how the ordinal encoding is done. One encoding, for example, for certain color categories. These are the various color category it is mentioned: red, green, yellow, yellow, red, and so on. If we wish to continue. Here there is no ranking. Identify the unique category and represent them in binary columns. What is the unique color code? I can select unique category. One is red, green, yellow. So now I will represent them in terms of binary column. Okay. So let's represent this in binary column. Okay. So when red and red is there, 1, remaining is 0. So this is what we do, binary and binary representation, right? Like this. When green and green is there, 1, remaining is 0. When yellow, yellow is there, 1, remaining is 0. So similarly, again if yellow comes, so it continues. The binary column representation continues. This is how, when we are identifying the unique category, that is red, green, yellow. For red and for green and for yellow, we are going to use the binary representation. In this way, one hot encoding is done. So now to represent the red, what is the code I will be using? 100. For green, 010. For yellow, 001. Again for yellow, 001. For red, 100. So we are using the binary column to represent. Hope you understand now. If the problem is given to calculate evaluation metrics, you should be able to do. If the problem is given to identify the error, various error, you should be able to do. And representing the data, whether in the form of ordinal encoding or one hot encoding, you must be able to do.